Okay, so today what we're going to look at is the um, area of a circle. And we're going to look at the area of a circle, and hopefully you've all heard that the area of a circle is pi r squared. But where does this pi r squared come from? So we're going to look at where this formula originated and how they came up with this formula. So what we've got here, we've just got a circle and it's divided into 6 parts. Now we could divide it into more parts we wanted, but we're going to start with 6 so we can see what happens. Now, the first thing, we're going to straighten out this circumference. Here's the circumference of the circle. Now, let's straighten out this circumference. And what happens as it flies down here? There it is, 2 pi r. Now, we should have known that is going to come out to be 2 pi r. That's the circumference of a circle. Now, let's rearrange these little triangles. So what we're going to do is we're going to split all these sectors up. So let's split these up and see what happens to them. And I might just stop it there. I wonder where this point is going to land on this line. Is it going to land out here? Is it going to land here? Well, when you think about it, this black line was the circumference, and all these little arcs here are the circumference as well. So it should land right there. Let's see if it does. Oh, and it just missed a little bit. Why did it? Well, it missed a little bit because all of these are a little bit longer, aren't they? So this line is the actual circumference. This isn't. This is the actual circumference as well, which is a little bit shorter. But if we divided this thing into lots more parts, then it would become very, very well. It would become the circumference, wouldn't it? So what are we going to do with these 6 sectors? Remember, this length here is 2 pi r. This length is the radius, or r. So let's see what happens if we fold this back. Remember, these 6 sectors are the area of the circle. That's what we started with. These 6 sectors were the area of a circle. Now we've split them up. Now we're going to put them back onto each other. And what we've got is some sort of weird parallelogram, perhaps. Not really, but it's sort of like a parallelogram. What's the area of this parallelogram? Well, the height is r times the base, which isn't 2 pi r anymore. It's half of 2 pi r. So what you get is half of 2 pi r is obviously pi r. So what you get is r times pi r, which is pi r squared. So that's exactly where the formula comes from, which is really quite nice. Now, I know what you're saying. Well, this isn't exactly half of 2 pi r, and this isn't really the height. It's fairly close to the radius, but it's not maybe. And it's a parallelogram, which isn't really a parallelogram. But if we divided it, as I said before, into lots and lots and lots and lots and lots and lots and lots of little triangles, then what we get is that parallelogram now is looking much, much, much more like a parallelogram. Or a rectangle even, and what's the area of this rectangle? It's the height, which is r, times a half of 2 pi r. So pi r squared. That's where we get the formula for an area of a circle, pi r squared. Let's have a look at another way people can do it. And if we just stop there, did you see what happened first? What we're going to do, we're going to peel this circle down. So here's the circle, and we're going to peel it down. So the first thing is that the circumference goes to the bottom here. Let's start it again and see. And as it peels down, what's happening? That these little circumferences that are coming down are getting smaller and smaller. Why are they getting smaller and smaller? Because the circle here is getting smaller and smaller. And here it goes. It's going smaller, 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 and it's going really, really small until basically what we get is a triangle. What was the base of this triangle? The circumference. What was the height? The radius. So the circumference is 2 pi r times the radius. So 2 pi r squared, but we've got a triangle, so we have to halve it. That's how we get pi r squared. So if you want to look at it again, we'll start again. There goes the circumference, and then as this peels down, every sort of outside layer is getting smaller and smaller. And what we end up with is that triangle there. Half the base, so half the circumference is pi r times r pi r squared. So that's just two little visual helps to say, well, this is where we get the formula for the area of a circle from, pi r squared. Thanks.